Blanchat Manufacturing meets CAFS 2.0 standard. User-friendly. Ability to instruct the pump operator to effectively operate the CAFS system in under 2 minutes.
Okay, I'm going to work on user-friendly, teaching somebody that's never run a fire truck before. I'm going to get a person, they always infatuated with a fire truck, but they've never been around it to speak of. They crawl around on it and play it. I'm going to use my nephew, Chase. So let's get him real quick. Hey, Chase! Come here. Chase is my nephew here. How old are you, Chase?
8.
And you've never been on a fire truck, you played on them, but you've never pumped one, right?
Right.
But you have drove a tractor, right? Chase has been on the farm, so he's a little bit on the mechanical side, so he kind of understands this. I want you to think of this kind of like a tractor, okay? The hydraulics on a tractor and stuff like this. So now I'm going to try to teach him in about 2 minutes. This is going to be a little bit of a challenge because you've never been around a fire truck and don't understand anything, how to get this thing to produce a CAFS system, okay? You ready? Think of this here as your hydraulic levers, but you don't know what they mean. You know, tank fill, all this here. Look at the color. Black, black tank. Red, there's a hose on the back of this truck, it's red, it's called a hose reel. Green, there's a green hose right there, right? Yellow, yellow hose, whip lines, there they are. Now, that's covered that. This here, think of this as your controls of your tractor or a lawnmower. You want to start it up, you got to turn this on, and then you hit the starter button. Here's the throttle, kind of like a lawnmower, just the same thing. I'm not going to start it so you can hear me talk, okay? And this is your RPM or your pressure. You're looking at your pressure. When you start it, you start cranking it up, and we want to full throttle it, all right? Now, we also need to have foam. So to have foam, we just turn this off. There's a percentage. We want 1/10 of 1%. There's 2 ones on here, so to make it simple, we're going to put it on the 9. There's a 9 over here. You turn this over, put it on the 9. The third thing we need is we got to have air. You push this button in and pull this up, and your air will come on. You'll hear the pickup speed up, and you'll see this pressure come up. Now, since I'm on the end of the green hose, which lever are you going to use? Correct. Now, here's a trick. You take that, and you pull it all the way back. That there turns on the air and turns on the water, and it sets at 1-to-1. It's called a 1-to-1 mixture. That's what I want to initially attack with. Say I want to make it dry, and I go like this. You take it and you start pushing it back, and you watch me, and when I go like that, that means stop, okay? Or you just keep pushing, but you can't push it all the way off. Say I want to go like this, and you pull it all the way back, and I want to go more. That means I want to get more water. You raise this up, and you bring it all the way back. Say I go like this. That means shut my water off. So you take it all the way back, you got to raise it up and go all the way back there. This is kind of a safety lock. 1-to-1, then you start drying it up. If I want more, you just raise it up and bring it back. Now, if you hold this up all the time like this, you got all the control. There's no lock. Got it? Think you got it controlled here? Just relax on the whole thing. I know it's kind of intimidating. I'm going to just stand here when you first started and everything, so if you have a question. Ready to try it? Okay, I'm going to step back and let you do it. Okay, let's go. Yeah, you can hear it. Good job. Good job. Great job. There you go. You got a full throttle. What do you need now? There you go. Look at that. So you got it all. Ready? Remember what I told you? I'm gonna go down here and get on the end of the hose, okay? There we are. There's a one-to-one mix. Okay. There we go. Now, this kid that I just taught, my nephew, has just dried this foam up. Look at it. There's my set.
The hose line will only be charged with a firefighting solution. Firefighting solution will be water and foam solution, or CAFS. Under no circumstance will the attack line be charged with just air.
Under no circumstances will the hose ever charge with nothing but a firefighting solution. That means we do not want air in that hose, period. So if the air compressor happens to be on, the pump is operating, we want to make sure that valve does not turn on unless the way we do it here at Blanchat Manufacturing, our air is operated by electric ball valve. Okay, to get the signal to operate that electric ball valve is, first off, we pick the power up from the pump. Second thing is, the pump pressure has to be up to 80 pounds because there's a switch. Then it has to make sure there's foam in it. And then the signal is sent down to this valve. In this valve, there's a valve, it turns the water off and on. Also, there's an electric switch down here that it's on a camber. Right there, it clicks on, so that turns it. So when you're charging a line, you bring this all the way down, which activates that there. It will not turn the air on unless there is a foam or water solution in that line.
Instant CAFS. When the hose line is charged, there will be no more than a 2-second delay with the perfect mixture of CAFS.
Instant CAFS. Now, on instant CAFS, something you want to remember, you cannot water hammer CAFS because it's a compressible material. That's the reason I'll go just like this when I open this valve. And when you see that light come on, that means the circuit has all been completed. It's gone through here, it's turned on, and this light comes on at the same time that ball valve actuator is turned on. Instant CAFS. Start the pump, bring the pressure up. Turn on the foam system, turn on the air. Charge the line.
Absolutely no slugging. CAFS system will not produce the slugging effect.
Now, another one is absolutely no slugging. We got to distinguish between chucking and slugging. They're two different things. Both are being caused by the same thing. Okay, chuck is when this hose is just barely moving, it's going like this, or it's even doing about this much. You'll see his hand moving like this. Okay, slug is just like coming back. It's pushing him so hard. Think of slug is if I take him and slug him, he's gonna move. That's the difference. Chuck is I'm sitting there, it's like I'm patting him. So now let's explain why it's doing this. What it is the water is not being scrubbed inside the hose, or it's separating in the hose. So what's happening, you have a bubble of air, piece of water, bubble of air, you're starting to get bubbles. The bigger the bubble, the more you're gonna feel it. When it goes to slug, you're gonna have a real long bubble. Then all of a sudden you're gonna have a chunk of water, then a long bubble, then a chunk of water. What's happening is that air goes through real fast, and then that water hits the end of this nozzle, and that's where you feel that hit. Our system, what causes chucking, if you ever experience chucking on our system, there's only one wrong thing. It means it's not getting foam in the water. Slug, we're getting such a good scrub through the system, we're not going to get the slug because it's mixed so fine and it's holding it as it's coming through there. You're going to see the chuck, but you won't see the slug. I've seen people on slugging on some systems literally pick the firefighter's feet off the ground. It's hitting him that hard. So that is a dangerous thing. That's the reason we don't want to ever see this. Now, the problem I have here is I've designed my systems that it will shut the air off if you shut the foam off. So what we're going to do here is I'm going to take the foam system and I'm going to put it to 0. I'm going to fool the system. So where the system thinks it's on and stuff, it just has no flow. So that's where you're going to, so I get the foam out of the water, and it's all of a sudden you're going to see him start chucking. Okay, there's a 1-to-1. Right there, 1-to-1. Now I'm going to go to 0. Back to 0. What we're getting is the residual in the system. There's still a little bit of foam in this system, and it's picking that foam up. Notice how wet it is. Notice him. He's not. I'm going to slow him down on a flow and see if we can get it to chuck. There, it's starting to chuck. See that hose starting to move? There it goes. Now, I've got this cut all the way down to 1-to-1. Now I'm going to bring my flow back up. It stops it. If I go full flow, there's no chuck at all. The only way I get it to chuck is I bring my water down to a 1-to-1. 1 cubic, okay, there it starts chucking. There's 1 gallon of water, 1 cubic foot of air. Now I'm going to bring it on up. There's a 2-to-1, 2 gallons of water, 1 cubic foot of air. The chuck goes away.
Pump pressure variation. Pressure variances during operations on water and/or air will not affect the CAFS system.
Okay, now we're going to do pressure variation. Okay, there's full pressure. Bring my pressure back down. Up, down, up, down, up, down, up. Full pressure. 140, down. There's 80. 110, 120, 140, 150, 80, 100.
No foam, no air. Air will only come on if the foam system is activated, and air will shut off when there is no more foam concentrate in the system.
No foam, no air. The reason this is so important is that's what causes slugging or chucking, because the consistency the bubble is not being made inside the hose and held. There's a chunk of air because there's no soap in there. Okay, with this, we're back to this air valve again. Always remember this ball valve, which is an air actuator. We're getting a signal from the pump itself, so it's pressured up. The switch turns on here, and now it sends the signal over here. This signal comes over here to a relay, or the power comes to a relay. Now it's picking up a signal from here. If you don't have this on, the signal isn't opening, closing that relay, so it doesn't go any further in here. Say you have this on, but you're out of foam. That means the foam system isn't on, so the signal is not going to the relay, which will send the power on down to the switch, to the valve.
Flow control. The firefighter controls the flow at the nozzle. The pump operator only controls the mixture.
What I'm going to demonstrate here on control, that firefighter has control, I'm going to go full throttle, half throttle, full throttle, off and on, quarter throttle. I'm just going to do all different types of settings. And you're going to notice it does not mess with the structure of the bubble. It doesn't mess with the CAFS system. Okay, here we go. Okay, there's full throttle, half, full, half, full, half, quarter, 10%, full, off, on, off, on, off, on, off, and off. What I'm trying to demonstrate here, the movement in here doesn't bother the system. It's designed to do this.
Mixture control. Mixture control will be mechanically conducted inside the system and be operated physically with at least 3 hand-driven locking presets.
Mixture control. Now, what we got coming out of here right now is a 6-to-1, 6 gallons a second. Water, foam solution, 1 cubic foot of air. Let me show this. Okay, now I'm going to dry this up by taking my lever and reposition it in the second lock. And what I'm doing there is I'm reducing the water but keeping the same amount of air. Okay, now I'm adjusted in to a 1-to-1. 1 gallon of water, 1 cubic foot of air. Now remember, there's a 6-to-1 still in this hose. So you got to push the 6-to-1 out and then it'll go to the 1x1, and you'll see the difference here. The pump operator is the only one that controls this mixture. The firefighter is going to have control over the nozzle. Okay, here we go. Okay. That's a 1-to-1.
Bubble structure consistency. The benchmark for functional CAFS foam solution is to produce a product similar to shaving cream.
Okay, let's talk about bubble structure. Bubble structure is kind of self-explanatory. We want a solution like shaving cream is what we're looking for. So that is, the smaller the bubble, the more packing and sticking it'll go. So the structure is kind of a debatable item here, but the way I describe it, I don't want to see these great big bubbles. The bigger the bubble, the worse the structure is. I don't want to see a bunch of big bubbles. I want to see nothing but shaving cream. Scrub.
The mixing of water, foam solution, and air will be accomplished 100% before it reaches the hose line.
Okay, we're going to do scrub. 100% has to be done inside the CAFS system. I don't know how to get it and show this, so what I did is just, instead of putting the 200-foot hose on or 300 or 400 foot, so there's no hose on this, we just put a smooth 10-foot whip line. It's coming right out of the system, going right into that nozzle. So that's the easiest way, so you can tell that the scrub is going to be done 100% in the system.
Stream reach. CAFS has the same reach as water and can be sprayed into the wind the same as water.
Okay, see the reach? See how far we're reaching?
Reliability. You do not have to exercise the CAFS system to keep its operational integrity and efficiency.
Okay, let's talk about reliability. Reliability is when we arrive on a scene, we got to know our CAFS system is working. In order to make sure this is happening, a lot of systems require exercising. Exercising is when you pull the truck out and make it produce CAFS. Some systems require daily exercising, some's weekly exercising, some maybe goes to bi-weekly exercise. Our system does not require any exercising. If I have water with foam in it, in pressure, and air pressure, I guarantee you I will have CAFS perfectly. The exercising of this system is training too. So whatever you feel comfortable on the training side of this here, it might be once a month, once every 6 months, or once a year. So your training on this system is plenty of exercising for the accelerator controller.
Ease of maintenance. Total maintenance time per year is 1 hour or less.
Maintenance, let's talk about that. Before we can talk about maintenance, we got to talk about that there's 4 different systems in this. One is pump. The pump requires its own maintenance schedule. 2 is foam injection system. The foam injection system requires its own maintenance. Compressor. If you have a compressor or if you have a cascade, you'll bottle air. If you have bottled air, you got to fill the tanks. If you have a compressor, you got to run its maintenance system. And last is the CAFS system. That's what puts everything together and creates the CAFS. The accelerator controller requires no maintenance.
Warranty. A minimum 10-year warranty on the CAFS system.
Warranty. Now again, on warranty, you got to remember there's 4 different systems here. The pump carries its own warranty. Foam injection system carries its own warranty. The compressor carries its own warranty. The CAFS system carries its own warranty, and the accelerator controller carries a 10-year warranty.